Okay, now we're on the probability. Okay, so the first two, actually, I'm gonna put the first two into one. But probability, we're gonna use our counting that we used earlier to figure out probability. Now, probability, as an essence, is just gonna be what you want over all options. That's the easiest way I think about it. What you want or over all options. Okay, so let's say we're looking at cards and we want to know, for example, a red card. What's the probability of a red card? Well, there's 26 red cards in a deck, and there's 52 total cards. Now, what's the probability we wanted a club? Well, there's 13 clubs, and there's 52 cards in the deck. Now, if I said the probability of getting an ace, you would say there's 4 aces and 52 cards in the deck. Now, we can answer it 4 52. We could also do division, which 4 divided by 52 equals 0.077, or as a percent, which would be 7.7%. So we times this number by 100. Okay, so there's the big thing that we need to remember is just probability is what you want divided by all options. We'll go through a bunch of things for today. So the first thing we have to know is theoretical versus experimental probability. Okay, theoretical is based on the math of the probability. It never changes. Like for example, if we flip a coin, the probability of getting a head with a coin is 1 out of 2. There's one head side and there's two sides of the coin. No matter what, it's always going to be that. Okay, so it's the math of what's going on. Experimental probability is found through experimentation. Okay, so it's you actually doing the events. Okay, and it always changes. So, for example, if I were to flip a coin 4 times, and I got heads, heads, tails, heads, my experimental probability of getting head in this case would be 3 over 4 because I got heads 3 times out of 4. Now, these don't always match, but if the more trials you do, the closer it'll get. Like if I do it 1,000 times, it'll get closer and closer and closer. And the probability scale goes from 0 to 100, or 0 to 1. Okay, 0 being unlikely, 1 being more likely. A couple little words you may hear. Trial is one repetition of an experiment. An event is the outcome of the experiment, getting a head tail. And a simple event it consists of one outcome. What should we pop to next? We went through experimental probability. Now, the other thing we can use is simulations. Okay, I'll write this down here. So let's look here. Suppose you flip a coin 30 times and tails shows up 19 times. What's the probability of getting a tails? Well, first, this would be experimental probability because we actually flipped a coin. And we got tails 19 times out of 30. So the probability of getting tails would be 19 over 30. Okay? If you rolled 2 dice 20 times and a total of 7 showed up 3 times, what's the probability of getting a 7? Okay. So the probability of getting a 7 would be 3 over 20. And this is also experimental. Now, we can use simulations to do experiments. Like, for example, if we wanted to do a coin flipping experiment, we could sit there and flip a coin, or you could go online. There we go. We could go online and do a coin flipping numerous times. Okay. So I want to flip one coin. Let's say we want to do it 1,000 times. Right? Oh, geez. That's going to take for a while here. Anyways. Okay. All right. So anyways, single coin flipper. Let's try this one. See what that works out. But if we want to do something over and over again, or if you want to do something that would take some time, we can use a simulator to work it through. There we go. Number of tosses. Let's go 100. Okay. Check room stats. Boom, boom. And how come we don't have a simple start? Awesome. Okay. And this would be able to simulate what it's going to be. We just did 100 coin flips in about 5 seconds. Okay. And you can set this up like spinners or things along those lines. Where's my spinner? We can set this up if we had a, let's say, a 1 in 5 chance of doing something. This one. Here, 1 in 5 chance, right? Then we could set up how many spins we want to do. We want to do 10 spins and skip to the end. And boom. There's if we did, hypothetically, we did 10 spins with 5, we get an instant outcome, right? Which would make it a lot easier to do something like 1,000 reps of an experiment. Okay? So boom, skip the end, and there's our percentages there. It tells us our theoretical percentage and our experimental percentage there. Okay? And as you see, if I did 10 reps, right? Oops, let's reset. So if I did 10 reps, you can see how my percentages, my experimentals vary. I got some 30s and some 10s where it's going to be, I should be closer to 20. But if I do 10,000 reps, oops, I guess I can't do that many. My percentages are closer to the theoretical. Okay? So, with that in mind, so a married couple plans to have 4 children, use a simulation to estimate the likelihood their family have 3 girls in a row, then a boy. All right, so let's use the coin tosser. And we're going to go 3 reps. How many kids do we want? We want 4 kids. We're going to go 4. And let's say heads are girls, tails are boys. So we could do an experiment here. Oh, heads are girls. So we got boy, girl, boy, girl. We toss it again. And see, we could do this 20 times. So we didn't have it there. It was clear results. And you can keep doing this. Nope. Clear results. And see if we can get TTTH. That's what we're looking for. Oh, that's almost the opposite. I forgot there's with the crossed over here. Nope. And this is how you could use a coin tosser for a simulation for that. Now, if I wanted to figure it out, what's the probability? So we have child 1, child 2, child 3, child 4. The probability of getting a girl is 1 out of 2. Getting a girl again would be 1 out of 2. Girl again would be 1 out of 2. Then for a boy, it's 1 out of 2. So getting it would be a 1 in 8 chance. Now that's just getting 3 girls and 1 boy. Next chapter, we'll figure out exact order. Okay. Then, suppose here, Barry Bonds, the baseball player, bats 320. Okay, which indicates 322 hits, 20 hits and 1,000, or 32 hits and 100 at-bats. A simulation to estimate the likelihood. Well, oops, here's my simulator here. Let's go to random number generator. So what we could do here, and we could generate it. That's the exact question. So he's going to get 3 at-bats in a game. Okay. So I'm going to go here. We're going to run this 90 times. Okay. I'm picking 90 because it's easy to divide into 3. We're going to go in columns of 3. Now, since he bats 320, that would mean, hypothetically, he's going to get a hit 32 times out of 100. So for us, the numbers 1 through 32 is a hit, and 33 through 100 is no hit. Okay? So we're looking for how many times he has no hits in a game. So I can go here, I'm going to get my numbers, and then we're going to look here, and there's one little thing here. So I'm going to copy and paste this. Oops. Into OneNote so we can play with it here. So here's my numbers. So 0 to 32 is a hit. Okay, we're looking for, he has no hits. So here we go. That's no hits. None of those numbers are between 0 and 32. We have a hit here. We have a hit here. We have no hits here. We have a hit here. No hits again. And we can go through this. And this is simulating. Not sure how many games are simulated exactly. But count them after. So there we go. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 times out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18. 8 out of 18, he had no hits. So that's our probability. 8 out of 18, he had no hits. Okay? He had no hits 8 out of 18 times. Okay? And we could even go through and calculate all his hits and find his batting percentage in that simulation. Oh, I read that one. I think we're good there. So I'm going to pop to theoretical. A little more on theoretical here real quick. The big thing here is, we already did theoretical. It's the math of it. It's what we want over everything available, right? So if we're rolling a dice, okay, our outcome would be getting 1, 2, 3, 4, 5, or 6. What's the probability of rolling a 4? So the probability of rolling a 4 is 1 out of 6, since there's only 1 4 in that batch. Rolling an even number, probably rolling even number would be 2, 4, and 6, which would be 3 out of 6, or 1/2. Okay? Suppose a bag contains 5 marbles, 3 blue and 2 white. What's the probability we draw a blue marble? Probability drawing a blue. We have 3 blue marbles and 5 marbles total. Okay. Now, the complementary here is, what's the complementary of getting a blue marble? So complementary is everything that's not what you want. So in this case, if it's 3 out of 5 to get a blue marble, the complement would be 2 out of 5. Now 3 out of 5 is 60%, right? 0.6. So the way, if we want to figure out the complementary, be 1 minus 0.6 would give the complementary, which would be 40. Okay? So the complementary is the opposite. In this case, the complementary of getting a 4, and it's a little apostrophe. If it's 1 out of 6 to get a 4, the complement would be 5 out of 6. This one, the complement of getting an even number would be 3 out of 6, because this would be also a half. It just happens to cut it in half. Right? Oh, we already did that. So in our case there, the event A was rolling a 4. The complement would be not rolling a 4. Okay? Let's do this one. So, what's the probability of selecting a king in a deck of cards? So the probability of a king would be 4 out of 52. The probability of the complement of a king, what's essentially with this one, what's 52 minus 4 is 48 out of 52. Selecting a face card, there's 12 face cards. Probability of face card is 12 out of 52. So the complement of that is 40 out of 52. Okay. And I think we're good for most of that. I think that's all for today, and I'll put your homework in, and we can go from there.